Recording. So, hello guys. This workshop will be about everything DMX, as you can see on the picture. And today's tutor and your today's guide will be Andres Alvarez. Do I pronounce your name right?
Yeah, I'm quite amazed, but yeah, that's the right way to do it.
Okay, indeed. And then,
Okay.
in that case, I will give you the word. So, what will you talk about now?
Well, the idea would be to talk about what is DMX, how to connect all these weird lights that we see in every party that we go, any concert, any festival, and to show you how you can control this from VVVV and how easy this is. That would be like the main idea of the workshop.
Cool. So let me
Clear?
turn off my microphone. Just a second. Wait. Let me optimize for speed the team viewer. Yup. It's alright. And then you're running, baby.
Okay. Well, to start with, please, sorry about my English. I don't speak English very often, so I'm kind of rusty. So the idea will be to build one of these things. This is an Arduino. So you can build like your own DMX board and use it from VVVV in a safe way. What do I mean about a safe way? There are several DMX USB to DMX interfaces, but they are not really good at all. For example, never buy one of these cheap stuff. They are like super cheap, but they are like quite dangerous. The issue with this kind of devices is that they share the connection between your CPU ground and the DMX cable, and that's something that you don't really want, like never. So
why you don't want such thing?
is to build an interface like this one.
Why
because when you're working on the thing is, this is an electronic issue. When you have like a festival and you have maybe 10, 20, 100 different lights, most of the time they are connected from different cables, from different power sources, from different generators. So if all the connections are not, it's called grounded, they are not connected to the ground, or if any of this equipment fails, that power difference will be traveling through the cable to your USB port. That's something that you don't want. So,
and it can fry up.
Like,
it can fry up your computer.
Yeah. It can fry up your computer very badly. So that's something that you don't want. So what are we using now? We are using Ethernet. When you are using the Ethernet cables, I mean,
sorry that you're a little bit. Okay, we lost you again. Just what?
Oh.
Okay, your return.
No.
We lost you for a couple of seconds.
Okay.
So you were at Ethernet cables.
Okay. Yeah, the Ethernet cable don't share the common ground. This cable, they don't share ground with the computer or with any other computer on the network. So this is the way to go. So and we will be using an Arduino, this cheap board that you can use for anything. You can do an Ethernet interface with this. What we are going to use is this website. Let's go to English. These guys, they find English. They found a way to make an interface from an Arduino in a very easy way. Then we go to the schematics. The idea was to build the interface here, but this new soldering iron box don't work. So we want be able to do it live. But basically, the only two things that you need is an Arduino, any Arduino basically. It could be an Arduino Uno or an Arduino Mega. The advantage of using this one is that this Arduino have it's called WART interface or serial interface. So each DMX line will be using one serial interface. So in theory, we can do 4 DMX universe from this tiny thing. And the second thing that you need is this thing. This is an Arduino Ethernet. So the construction is quite easy. There's only one way to put the Ethernet shield here. Ethernet cable, USB cable, and then this is let me show you. This is the code itself. That you can download this code from this website, from Desk Control. And the only thing that you need to do here is to define if you're going to be using one output or 2 outputs or 3 outputs. It's supposed to work with 4, but it's quite slow. Most likely it won't work at the frame rate that we want to. So we just leave the code like this. We're going to use one universe.
Sorry to interrupt, but I never quite understood what are the universes in DMX. So is it like a group of devices?
Oh yeah.
Or what should we?
Yeah, you're
imagine?
right. I should be starting from here, from the theory. So
well, I sincerely didn't know that.
Yeah. Let me put this on in VVVV works. So I will be using as an example. No, well, this is not an example. This folder here that I will show you how to DMX. You can go to the VVV documentation. Mr. Gale made a great workshop in 2008 about DMX. Everything is explained here, but let me go through the basics very quickly. In fact, when I say let me go through the basics. Sorry, I have here a folder from that you can download, and here we have all the workshop files. So let's start with what is DMX. Let me use these files. On DMX, you have what is called channels. So let's start from the basics. RGB. Let's suppose that we have this super cheap Chinese RGB equipment. Sorry, fixture. Oh, damn. One second. Let me show you a good picture from these Chinese guys. This is the fixture. When I say fixture, suppose the fixture is the same as the equipment. When you're talking in DMX, they call fixture to each units that use DMX protocols. This is another super cheap DMX fixture. This have 2 red LEDs, 2 white, 2 red, 2 green, 2 blue, and the middle one is white. And on the back, you can see you have some switches. So those switches are to choose which DMX channel you want to use. So what do I mean with DMX? DMX channels, it's like, let's call it spread. It's like a simple, give me a second because I have, DMX channels are like a simple spread. David, can you see my monitor here? Is it clear?
Yeah, it is clear. It is absolutely good.
Okay.
Yeah,
okay.
I can see your patch clearly.
Let's start from here. Okay, great. A DMX universe, it's something like this. It's an array of spreads that goes from 0 to 512. So it's like 512 slices of information. That's one DMX universe, and each universe can be sent through one of these XLR cables. So on one cable of this, it fits only one DMX universe. And one DMX universe have 512 slices, and each of them have 256 steps of resolution. So 256 steps. Give me a second, David. I want to restart my VVV because it's like super slow here.
So is it more like MIDI, but just for like double everything? So in MIDI you have like 256 information, and all of them can go to 129 steps. In DMX you have 512 information, and all can go 256 steps, right?
That's right. It's as simple as that.
That's so nice. Okay then.
So yeah, the only thing about this protocol that it only goes in one direction. So it's only one way. The sender, it could be the computer or the ArtNet board or a table, a console, only sends information, doesn't get any information back from the equipment. And all the equipments are connected in series. So it's one next to each other, next to each other. So if you see this DMX Lite have this cable here, and this is like a Y cable. Usually this equipment have like a one input and one output, but really it's like a Y cable. The same information that goes in, it's the same information that goes out. There is no trick about that. So you have like the male and the female, and that's it.
What can go out from the lights?
Yeah.
What sort of information can go out?
What kind? Sorry?
What sort of information go out from the light?
Yeah, that's the thing. It's only the information that goes to the lights. It's only a number. Remember, it's a table. Our spectrum, it's 512 channels per universe. Each channel have 256 steps of resolution. So most of the lights, for example, this one, this has 7 channels. So you're going to ask me, okay, why do you have 7 channels if you have only 4 colors? So you have red, green, blue, white, and then you have what is called dimmer. The dimmer, it's like the intensity of these other 3 channels. So if you're thinking in a VVVV way, that's like stupid, because you can only use 4 channels, and that's all the information that you need to control these 4 lights. It's 2, 2, 2, and 1 in the middle. Why do they use 7 channels? Okay, most of the fixtures have channels for different functions. Most of them have a dimmer channel. That's like the master of the fixture. So it's like you're doing RGB. Let's see, RGB split. For some reason, my VVV is super slow right now. So it's like you have it's super slow. Something's wrong here. Give me 1 second. You have RGB, and then you have one dimmer. Let me see if I have this XLR cable. Let's go to the cables. Then we will go back in the channel thing in a second when we use the other software. Let me finish with the electronic stuff.
Okay.
I was telling you this cable have 3 connectors. You have ground. To send a digital signal, you only need like 1 cable. It's up or it's down. Then you need a reference cable, that's the ground. So with 2 cables, you can send a digital signal. So why are we using 3 cables? This is like a great explanation. This is the thing.
Oh wow, that is some catchy help patch down there.
Yeah, there is no way to do this like better. So that's why I'm using their file. So this is this thing here. It's the cable. So instead of using, let's go back to instead of using only one line, one ground, and one cable to send the data, they are using two cables. So let me show you the data. This is how the data goes inside DMX. Basically, if you have two cables, now let's go back. Let me put this example with audio. If you are working with professional equipments, most have like balance. It's called balance signal. It's a cable that is using, for example, to send you only the right channel. I'm using three pins: ground, positive, and negative. So what is positive and negative? It's like the same signal you can see here on the screen. Let's see if I can pause this. On one cable you have like a positive signal, and on the other cable you have the same signal but on the opposite direction. So when the signal arrives to the equipment, to the desired equipment, the other equipment is going to flip the signal again. It's going to add them, and it's going to divide it by 2. So long story short, you keep having the same signal that you have on the first cable. So why you're doing all this stuff? I mean, copying one signal, put it on the opposite side, send it back, flip it again, add it, and divide it. Because by doing that, you are avoiding noise. What do I mean about noise? If you to that cable, you add another cable with power, for example. It's breaking up.
Just it breaks up a little bit. So can you repeat the sentence?
Yeah. If you have a cable that is going to be carrying a signal, for example, an audio signal, and you put that cable next to another cable that it's having like a power cable, you will be hearing like a 50 hertz song and noise on the background, because the interference from one cable is going to the other one. But if you are using a balanced cable like this one, and here you could add noise, it's quite hard to see here, but let's see if I can, let me, yeah. This is a screenshot of what I was telling you.
That's clever.
This is like, let me, this is like the signal, the blue one. Okay, so let's focus on this area. This is the same signal, flip it around. And this is the signal multiplied by 2 that is going to be divided by 2 when arrived to the receiving equipment. This sinusoidal, or this signal that is going up and down here, it's the noise coming from a different cable. But what happens when the noise gets into these two lines? It's going to be added on the two lines at the same time, because both cables go to the same direction. So when this signal is added on the two cables at the same time, when that signal gets to the receiver and it's flipped around, it's going to be canceled. So you won't be having that sinus wave anymore in the middle. So by using this balance cable, you avoid noise. Did you understand anything, David?
I quite understood anything. Yeah, it's only... yeah, Vespam is here. So he said that grab the package with the DMX cable patch here. Or is that... yeah. But nice to see your face, Bo. And he said also.
Well, basically, the idea of using two cables is to avoid that noise. So when you are building the Arduino boards, the third part of the equipment that you need, it's these tiny schematics. It's a tiny circuit that is here, that is going to, from the signal that is getting in, this circuit is going to be creating the same signal in the opposite side. basically the Arduino signal can be made by the Arduino integrated circuit. I mean, this tiny chip can generate that signal, and there is another chip that is needed to complete the board. That is this tiny SN76175 176 or max 485. It doesn't matter. That's the schematic that we have here, and this is how you can build the schematics to use it. But don't worry about this. Most likely you won't be building the interface now, or we can do it on a different date. Let's continue with the theory about the DMX. So David, yeah, DMX is like MIDI. Basically, each fixture or each light, you need to tell the light which channel or which channel this light is going to be responding to. So, for example, this one here, these are my DMX channels. This is a very good example file. Close this. So when I move the channel from here from 1 to 16. Give me 1 second, David, because my VVV is like super slow for some reason.
Okay, no problem. I'll try to restart it, or try to like start another version maybe.
Yeah. Not sure if I have another version right now. I guess it's something related with the webcam because yeah, now it seems to be working.
Okay.
Cable, we already opened that. XLR. Okay, this is the schematics from the XLR cable. Sometimes they have 5 pins, sometimes they have 3 pins, but let's continue with the topology.
Wow, that is something over there.
Sometimes you have the light. Yeah, sometimes you have, for example, this simple 16-channel light desk. So this goes to a dimmer pack. It's a device that is going to convert from DMX signal to high power output. So you can connect any incandescent light there, and you can dimmer or put the light bright or control the light. This is a dimmer pack. Yeah, you can see like this. From the outside, you get the DMX cable in and out, and then you have all the tiny cables to control your lights.
What is the usual price range for such thing?
No, DMX equipments are like super expensive, but it really depends. This DMX equipment is expensive, but this DMX light, for example, well, Argentinian price are not like a reference point, but let's think like in the international price, this could be around $50 US, I guess, $70 US.
Oh, that's not too bad.
This is like no super expensive.
Yeah, but all the dimmer boxes, I guess
that's not too bad.
I guess they're multiple thousand or at least multiple hundred.
Yeah, it can go to 1,000. So let's say that you are doing DMX, and let's continue with the protocol. You have your DMX sender, that it could be your Arduino board, or it could be that cheap USB cable that I show you, or it could be a professional ArtNet board that looks like, yeah, inside it's still like an Arduino. Most of the people build them themselves. ArtNet node. So yeah, let's continue with the. There are different ways to connect this kind of stuff. You can put like the output of the interface to one channel to one. I mean, this one goes to a board. This one goes to one light. From that light goes out to a second light, and you do like a daisy chain among all the lights, and that's it. That's not the good way to do it, because that signal is going to be degrading, and the lights in the back are most likely they're going to fail. So that's why you have what is called the splitter. These are these devices. So on one end you put the signal from your board, and on the other output it's like the same signal replicated. It's the same signal, so you have different cables. But again, let's move on to the VVVV parts, so we can do something here. So what I would like to do is to show you how to build a tiny DMX fixture, and I'm going to be using a software, Grandma onPC. Grandma, it's like the most, this is like the brand. It's need to put DMX, if not you get pictures. This is a professional lighting desk. Yeah, it's
I thought the previous one was the professional lighting desk. Don't switch on the lights.
Yeah. So this is like a professional lighting desk, or you have other like Chamsi's desk. This is another Chamsi, another professional, very used equipment. Most likely, all the stuff that you can do from here, you can do it in VVVV in a very simple way. You have other advantages, but there is anything. I mean, anything can be done in VVVV. As simple as that. This is more practical. More people use it, but you.
Well, I guess you have a physical.
Let's start. Let me go.
So you have a physical interface with the hardware. That's it, and people just usually it feels better with that dedicated physical interface with the knobs and little slides, and, you know, touchy.
Yes.
People
feel that it's something that is more expensive would be like more professional.
Well, at least despite of VVVV, for example, as a hardware provider, they can guarantee it will not fail most of the time. Whether in VVVV cases, you know, it tends to fail a lot of times. So I guess that's the kind of balance you want to get for.
The thing is that VVVV guaranteed that it's going to fail, and it does. So they are doing what they say. This lighting desk, they guarantee that they won't fail, and they do. So why? It's a computer. I mean, inside of that lighting desk, there is a simple computer. So something as simple as that.
Okay.
So, let me show you this RGB fixture. This is a quick way to understand how a DMX equipment works. So basically, now it's working fine. Okay, these are my channels. So it can go from 0 to 255. And here I have control of 16 channels, but this could be this could be like, I mean, this should be 512. Let's use 16 to explain what's going on. So this dimmer pack, these are the lamps. Let's move this a little bit down so we don't get confused. Okay, so this part here. It's my lighting control software, whatever. This is the cable. Inside here I have 16 channels. It should be 512. Let's do 15 just to be clear. So I'm sending here my table of 16 channels, as simple as that. So here I can see my table. If I move this, it moves on the table. That's it. So starting address, what is this? Starting address is the way to tell the light or the dimmer or any kind of DMX equipment which address is going to be listening to. So this guy here on the back, so these switches, this is the way to tell the light which channel I will be using, and this is in binary. The first one up is 1, the second one up is 2, the third one up is 3, the fourth one only 4, and so on. It's binary. There's no trick. So if I tell this light to be number 1, this light is going to be listening to the first 7 channels because this is a 7-channel equipment. If I tell this light that it will be number 10, it will be listening to channel 10, 11, 12, and so on until 17. So this is like let's call, yeah, this is like a get slice. If we are talking VVVV, this is the get slice input, and the bin size is the amount of numbers that this equipment uses.
Is it
I think that's a better way to explain it, David, right?
Yeah, that's a good way. Well, is it a regular behavior, standard behavior with DMX receiving devices, so which has multiple channels to listen to?
Yes.
Or it's okay, so that's its
yes.
standard behavior. It's like you can.
Any DMX fixture or any DMX equipment will have a display at some point or a switch. For example, this one. So you can put which address you are going to be using, which address you are going to be listening to. So, for example, you can have 10 or 1,000 of these equipments, one next to each other, and you can tell them that all of you are number 1. So on the first 7 channels, you will be tuning all the lights on and off.
Well, I mean, okay. I meant for.
If you want.
I meant, for example, that the starting address kind of behaving pattern. So is that a hardware specific thing, or you can bet your life on it? It will work like that way. So if a DMX device has multiple channels to listen to, will it always like start? Or you are getting the starting address or something? Yeah, I can imagine it's a standard.
Yeah, it's another way. They get that switch on the back. It's the same as this get slice node I'm doing here.
Yes,
so
yes,
this will be the amount of channels. For example, on this light that I'm using here, it have like 7 channels. And if I tell this light to be on number 1, I will be listening to the first 7 channels. One thing about DMX, we don't have 0. I mean, the first channel it's 1. On VVVV, the first slice is 0. So here, the first one, it's 1. So we need to be careful with that.
Oh yeah.
So let me show you. Let me explain you this dimmer. For example, a dimmer. If I turn the number 1 on, this dimmer pack, it's going to be listening to number 1, 2, 3, and 4. So 1, 2, 3, and 4 turning on. For example, here we have, and if I put this on channel, I don't know, channel 8, number 8 will be my first light. Let's explain this with the RGB light. This is a standard RGB fixture. Let's connect the DMX here. So if I put this fixture in number 1, I have red, green, and blue. That's it. But let's do this in a more complex way. Let's move on to what you guys want to see, because I won't be teaching you much about VVVV here, and we can't do the electronic parts because this one is broken. So something more interesting.
Oh, it's the broken soldering iron, isn't it?
Okay, so yeah. So what do I have here? Now it's getting more complicated. Remember I told you about this about this lady here? No, not this one. This lighting console. This was the first one. This is the it's called grandma full size, because it's full size. This table can output like 16 DMX channels. This one is the same, but you can buy. It's super expensive. It's called 2.0 node. This guy here. This guy here. It's a DMX interface. So It's like the same as this guy here, but it was meant to be used with this software. So why we're going to be using this software? This software can send DMX, this software can send ArtNet information to be used with this DMX interface, but it only works with this DMX interface. It won't work with any other interface. So you can't use this software with an Arduino, for example.
Just a quick question though.
With this interface.
Just a quick question though. That what is the difference between DMX and ArtNet?
Okay, sorry, David. You interrupt me. Let me go here to my workshop files. Oh, you know what? I closed my folder here, and I have like 7. Let's put it like this. ArtNet protocol is basically DMX over TCP.
Oh, okay.
So basically, it's just sending DMX data on TCP. But
that's it.
We have one major advantage. On one Ethernet cable, you can fit 65,000 of DMX universe.
Wow.
So
okay.
On one Ethernet cable, you can have 65,000 of this cable. So besides DMX, I mean, if you're using TCP/IP, you can use standard Ethernet cable. You can use Wi-Fi devices. Everything is like better if you're using ArtNet. But all the equipment still, all the fixtures, all the DMX still have this cable. Some of them already have the Ethernet connection. So you just plug the Ethernet cable. But there are thousands of equipment already on the market.
Oh, I'm sorry, your voice got broken over. So, we're waiting to get the voice recovered.
Better, blah, la, 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 la.
Hey, it's done back now. Okay. Okay, it looks like it's going again. Well, we're still trying to. Yeah, hey, I can hear you now. Okay.
Okay. This equipment, for example, can you hear me now? Okay. So in the future, everything will be all the equipment will be ArtNet in the future. But right now there are many different equipment already on the market that still use DMX cable. But moving on, we're going to be using VVVV to create the ArtNet protocol that is going to be compatible with any DMX equipment, and we're going to be using the grandma onPC software. This is like the old version. This is the new version. So we can visualize the lights that we are going to be sending from VVVV. So from now on, we're going to be starting a super simple grandma onPC tutorial. So this is the onPC software. We're going to start a new show. Here, all please. Okay. That's it. David, are you there? Can you hear me?
Yeah, I can hear you. I can hear you clearly.
Okay, great. Okay, so this is the DMX software. And then, okay, so let's start. I'm going to create a fixture table. So from here, I will be able to see all the equipment that I have on memory. Right now, I don't have anything. And from here, I'm going to create what is called a stage. So it's like a super cheap 3D visualization. And from here, I'm going to create a pool of views. So you need to click Store, view number 1, please. So every time that I press this button, I will be getting again this layout configuration. Basically, this software, you have like this grid, and from here you can create your tiny windows, and you can move them around. So this is how this software works. So right now I just made a fixture table, a stage view, and a view table. Now I'm going to add some fixtures or some equipment. So I'm going to do setup, patch fixture schedule. This will be my layer name, layer 1, doesn't matter. And from here, I'm going to be adding the equipment. So this is a main important part of what I want to teach you today. Let's say that you want to control.
Why do you need to know the equipment? Or of course you know the equipment you're using, but why do you need to specify it in the software?
Because the protocol is only one way. The table don't have any idea what's connected to the cable.
Okay.
So that's why you need to be sending. You need to be sending the right thing. No. If I just put any equipment here, and I connect this light, and I start playing around and moving my settings, maybe this is going to turn on because channel 1 that turns on the red pixel will be jumping around. But I will visualize this in VVVV, and this will be something easier to understand. So right now, just follow me on this.
Right.
I'm going to create. I'm going to be adding a very complex light, body light 2000. This is a very good equipment with many different channels. So this will be like great for our representation. So manufacturer, body light, yeah. Equipment, VL1000, yeah. Let's try this one. And here it's going to tell me what each channel, what it is. First one is dimmer, second one is pan, third one is pan fine. I will explain this. Let's say this is X position and tilt is Y position, and all the different channels. Don't worry right now, I will get it here in a minute. So yeah, let's choose this equipment, body light 1000, import. How many do I want? I want 4 of them. Let's look back, yeah. Apply, close, save, close. Okay, so this is my 5 channels, my 5 equipments, one over each other on this super cheap 3D visualization system. So if I select them and I go to dimmer and I turn this on, I will be seeing that tiny beam of light. That means that the light is on. So let's do something more advanced because it doesn't make sense to do this. So what this software, I mean, the reason why I want to show you this software is because this software is free and it has a great 3D visualizer. So that's what we are going to be using now. This guy here, it's the 3D visualization software that works with this guy. So first of all, we need to set up the network. I'm going to go to setup, network configuration, and I'm going to create a session. Leave, create. So here, you see right now I don't have any session here. When I choose create, I will see a session here. Okay, so I can do join. And now, yeah, there we have our tiny light. Let me close all this. Okay, so here we have our light. And let's move on. Let's see if I can fit the 2 of them on the same screen. David, can you switch the stream to my other monitor?
Yeah, sure. I can switch if if you don't mind.
Let's try that because
Yeah, because the other one has a white screen and this is another format. So I'm switching now just to make sure that your browsers and everything is good. Okay, I'm switching to.
Yeah, I don't have any.
So,
okay.
Yeah, it's better now.
It works?
Yeah, it works. It works fine.
Okay, so now, now I have my lights here. And let's go back to the software. From here, I'm going to select these 4 lights from this panel, and I'm going to do setup. From here, I can change the Y position. You can see that it moves on the 3D software or the X position. And I'm going to do align and click this, and I will do like, so now I have like a simple spread of all my lights. So these are the lights. I won't be very deep into, I won't be explaining very deep how the software works because it's like a pain in the ass. So we're going to do this from VVVV. Let me show you the simple thing. I can open the dimmer here. Dimmer is like the master. So we have all the lights, the position, pan, and teal. So it's like a good visualization software. And then you have Gobo. These are like the figures that the lights are going to be projecting. And I have the color on RGB white. So I want to do all this from VVVV. So how do we do this? As I was telling you before, this software can send ArtNet data. If you have one of these boards, this is an ArtNet board. This software won't be sending any ArtNet data unless you have this device, because they give you the software for free, and this is like, I don't know how many euros. This is like super expensive. So it doesn't make sense that you can send ArtNet data from here and use an Arduino or any other Chinese DMX device. So this software only works with this one. But this software can receive ArtNet data in order to visualize your show and to prepare your show to later be used on original equipment. So how do we send data from VVVV to this guy here? Well, first of all, we need to set up the network. ArtNet only works on on IP2 networks. So I have a IP2. ArtNet only works on 2.xxxx or 10.xxxx. We will be using 2.xxx. So we need to manually configure your network interface. I need to have your IP address to use your Wi-Fi, for example. But you also need to have an IP2 address. If not, this won't be working. So this is the first thing to check. So do I have an IP2 address? Yes. Okay. So let's do setup. Network control. I started the show on the IP2 address. Okay, so this is okay. Network configuration. No, sorry, network protocol. Here I need to activate ArtNet input, and I need to add an input. So this software now is going to be listening to any ArtNet data from the universe 1 until the universe 8. So right now everything is okay, it's activated. How do we check that? Let's do the following. Let me erase this window and then erase this window, and I'm going to create here a universe pool so I can see all the DMX universe that this software is working on at the time. And I'm going to create a DMX channel window. Let me change this to 10 channel. Okay. So let me show you this. I'm going to select fixture number 1. Oh, sorry. Let me store this here. Okay, so now I can jump from one view to the second view. Clear, clear, clear. I'm going to select the equipment number 1. Sorry, this one. And I'm going to check the DMX channels. So when I move something here, you can see that this equipment is using, I have the selection here, from channels 77 until channel 95. All these are the channels that this equipment is listening to. So if I open the dimmer, most likely on all equipment, dimmer is number 1 from the equipment. So if this equipment is listening to all these channels, number 1 will be 77. So when I open the dimmer, I will be opening, the light will be on. Okay, so I want to send this table from VVVV. So how do we do that? Let's open a VVVV empty patch. And it's as simple as this. DMX sender. So 512. Here I need to specify the 512 channels that I will be sending from VVVV. The time I'm going to be using for. Here I need to put the IP address of the DMX interface that I will be using. If you're using ArtNet in unicast mode, here I need to enter the IP address of the board. So this information goes to the specific board. Or I can do broadcast. It's the same.
Unicast means it will be just addressed towards a single DMX receiver, right?
To a single DMX receiver, yes. Or you can do, and sometimes you can do, I mean, on one DMX receiver you can have multiple channels, multiple universes.
Okay.
But yes, unicast, it's going from your PC to only one board that can have one or more universes. If you're doing multicast, you're doing broadcast. Most likely, a broadcast is PCUs, so it doesn't matter what IP address you have, it always works. So network setup is like easier. And this is the do send command. If I leave this on, it will be sending one package after another, and most likely it's going to lag my network. So a good workaround is do a spectral value here and a change nation. So at any given time that any of these number change, I will be sending only when this changes. Okay?
It might be wiser to just connect the change to the spread and then use an OR spectral node.
Yeah, but yeah, I remember I won't be teaching you VVVV today, so when I finish, then you will tell me how to do it better.
Okay.
This is like the cheap way. This is like the stupid way of doing it, and it works. So after this workshop, I'm sure that you will be getting like tons of idea of how to do this better.
Okay.
At the moment, let me show you this way. Okay, so what I want to do now is to check on this software if I'm getting this information. No, I'm not getting it. Let me check. I will be doing this. And let's allow it to a different view. No. On this view, I have the network configuration, network protocols. ArtNet input, yes. Okay. So right now, I should be getting. Give me a second, baby, because I made a few changes here.
It's all right. I mean, usually I don't have working stuff either most of the time. But I want to show, you know, it's a simple case when you want to show something that is the only and exact moment when it doesn't work.
Yeah, that's the annoying part. Okay, so I have the IP2 address. This is weird. Let's start. Give me a second. Back up. Let's show workshop. Okay. So, okay. View number 1. Good. Right now, I'm not getting the data from. I'm not getting the data from VVV for some reason.
Maybe if you
This
set.
happens very often.
I don't know. Maybe if you set your IP address, well, like just the one IP address, not 2 IP addresses for the same card. Maybe that that would make it.
Yeah, but the issue is that I will be losing the internet connection.
Ah, yeah, indeed, yes.
So
that's that.
That's the problem. This problem I'm having right now, it's very frequent. Yeah, now it's working.
Nice.
I don't know. Basically, no, yeah, I know what's going on. You need to be sure that you have all your other network interfaces off, and you have the one that you are going to be using with the 2 IP addresses.
Oh, okay? Wow, okay.
So yeah, that's the trick. Yeah, here I have the 2 items. Okay, so how do we know that this is working? Let's erase this view so we can do it from scratch again. I have this this software is empty right now. The only thing that I have at the time is the let's start let's start from scratch. So we go through all the steps again. Don't say okay. I'll write this in file, yeah, whatever. Okay, setup, network configuration, leave session. I need to select the 2 IP address, create session. Sometimes it would ask you to restart, so I will restart, and let's go again. Okay, so setup, network control. I'm on IP2. Okay, that's cool. That's cool. Create session. Okay, now I have the session created, and from here I will have a fixture table so I can see my equipment. From here I will have a DMX. No, this will be later. From here, I will have a universe, so I can see whenever our information from here is getting into this file. And from here, I will have the super cheap stage view that I will always use. Stage view, this one. And I will add a view, a pulse view. So I'm going to say this layout window to the view number 1, please. And on the number, yeah. Oh, yeah, that's it. So setup, network protocols. Okay, I need to activate ArtNet input, and I need to add an ArtNet input here. Okay. Now I'm going to create my equipment. Setup, patch picture schedule, layer 1, whatever. From library, I'm going to use very light 1000, and from here, yeah, I will select this one, and I'm going to put this 4, apply, okay, yes, got it. Yeah, now I have my 4 equipments here, one over each other. I'm going to do setup, but it's here. In here, it's the setup, so I can move the equipment. I'm going to select align, and I'm going to move them next. So we have the 4 equipment here in the middle. Okay, I'm going to save, backup, save workshop as workshop. That's it. Okay, now let's open the visualizer program. Now I should be getting views.
Maybe you should connect to the session.
Yeah, yeah. I love this window. You click here, connection standalone. You need to join. So this MAFD is going to be joining the session that is going to be created from here. Okay, yeah, there I have my 4 equipment. Okay, let's put this here. That's it. Okay. So let's move something here. You see that when I move this, everything gets messed up here. That means that it's working because that ArtNet light is blinking here. It's going to be blinking when it gets any information. But what's going on here? Let's see. Remember that I told you that 0 will be like the dimmer. You see that it's blue. So first, we need to know how we are going to control this equipment, how the DMX channels works on this equipment. So the reason why I'm choosing this software is because if you want to control, I mean, you, David, or any of the guys who is listening, if you want to control any light that is on the market, for example, I don't know, Clay, Paki, Sharpie, for example, if you want to control this guy, you need to know the DMX channels. So you can either do DMX Sharpie, DMX table, no, DMX table, no, I don't remember, yes. And you get a table like this one, where you have all the channels explained, but you need to have internet access, and if you have this software, you can use this database, like you are adding a new layer or a new equipment, and when you choose a library, you choose here Clay, Paki, Sharpie, and here you have the table. Or here you have the information on how you're going to control the light. Okay. Now we have 4 body lights. So body light 1000. This is the table that we're going to be using. So let's use this advanced software to leave this handy here. Okay. So this we're going to leave this here so we can see this table. Okay. Cancel here, whatever now. Let's go back. We have our 4 equipments, and if we send data from VVVV, something it's doing something, but we are not quite sure what's going on. So let's put this clear. First of all, we need to see what's going on the DMX side. What do we have at this time on the channel? On the what information do we have on the DMX channels? So I'm going to delete these 2 windows, and I'm going to create a window with the DMX. So I'm going to say store view number 2, so I can jump from this window to the other one. Let's select this equipment. Let's go to the table. As you can see, when I select this equipment, on this side, you see that this row is like highlighted in yellow. This means that from channel number 1 to channel number 19, these channels are from this DMX light. So if I move the dimmer, you will see that number 1 here, it's moving up, and the dimmer is moving up. So that means that if we do from the VVV side, let's do like this. I do like an eye spread, no, instance noodle, eye spread from 0 to, David, from 0 to, what number should I put here? 500 and, David is not there. So from 0 to 511. So here, I have 512 channels, and I'm going to multiply this by 0. So here, sorry, 512. So here I have, David, are you there? Because I'm not sure if...
Ah, yeah, sorry. Just, I was...
sorry.
Yeah, because what?
So, I'm creating here an empty table with 512 slices. from 0 to 512.
Yeah.
And multiplying this by 0, so this table here, it will be empty. Okay?
Yes.
And we can check that we have 512 channels. So this is what I will be sending to my DMX interface. We'll be sending this. So right now, at the moment, I'm sending anything, and I'm going to.
You have to.
Slides.
You have to send. You have to send all the 512 slices with the DMX node.
Yes and no. Let me show you why no. If I send a vector of 4, you see now that I have 100, 100, 100, 100, and when I move something, it's moved all over the computer.
Yes.
Because this 4 channels will be going, it's going to fill the 512 channels. So we don't want that. We just want to send, we need to send data only on the places that we know that we want to send data.
Okay.
So, if I use set slides, and I put this one here.
Yep.
Sorry. Set slides, spread. Spread here, output here, and input. Now I have control of the light of that one.
Okay.
So this is like the first step. Okay, so let's suppose that we want to move this light from left to right. We need to use channel 2 and channel 4. If I select here channel 2, wait, we will need to do this. We need to add another set slice here. Then I will show you a better way to do this. This is like the stupid way of doing it.
Well, you can spread the index part of the set slice too.
Yeah. Let's start doing it on the right. Basically, what I use is constant spread, and let's say we have 19 channels. I'm going to count how many channels we have here, and I'm going to bin size. I think I was doing this bin size here, index, and this will be the address. This will be DMX channel number 1. Remember that this can't be minimum value, it's 1, maximum value 512. This can't be 0. So if this is number 1, I need to subtract 1, so now I have the 0 from VVVV. So this one goes to here. So if this is
the DMX channel
right,
conversion.
Yeah, that's right. Let me check this. I'm doing something wrong. Input. Oh yeah, and the input. No, sorry. The count goes there, and the input goes here. Yeah. Okay, so I'm moving. So by doing this, then when this area here will be like a different patch, because this will be a patch of this later on. Let's go back to the lighting software. So here I have lighting. I have the master, so I can turn it on and off.
Nice.
Let's say that we want to do color. Color, we have color here on number 9, 10, and 11. So 9. Okay, so 9, 10, and 11.
Let's do a color IO box in it.
This is, yeah. The thing is that we will have some trick here, because when you do RGB split, this is not RGB. This is why. Oh, something I want to. If we wait a long time, like 10 seconds, this information will be lost, and the light is going. You see? Now the light is going to turn off by itself. So a way, a workaround here is like.
Why is it doing that?
Well, it's like.
Why it have to turn off?
That's something related with the software.
Okay, maybe because it's trial software.
If you're not sending data. No. If you're not constantly sending data, it's going to ignore. The reason is that the ArtNet protocol should be getting. You should be getting like packages in 44 hertz, 44 packages per second.
Okay.
We sent one like 10 seconds ago, so it's like the timeout of the protocol.
Oh, okay, cool.
We can cheat that by doing something like this every half a second. Just do a send. That's it. All right. This is not RGB. This is CMY conversion. So on some place,
it's actually CMY.
I should have.
Wow.
Yeah. In some place I have CMY.
Do you have a conversion patch or something? Ah, there you go.
Yep, this one.
Nice.
So basically, it's the color. I didn't make this. I think Ali, a friend. No, he didn't do it any. He didn't do it either. These are all from KL.
Okay.
So let's go back. CMI. So this goes. Cyan goes here. Magenta goes here. Yellow goes here. No, sorry. Yellow goes here. So if I'm right, yeah. Now we have the color on this side.
Oh, no, actually.
I think these are like.
Yeah, okay, now it's more like it. Yeah, that's very cool.
Okay, so next thing that's we want to move the light from left to right. So this one here, remember it was the master. So this is going to turn it on and off. If we want to move the light, we need to use number 2 and number 4. So number 2. This is called here it's called pan. So let's call it pan. Pan. So here we will find some problem. We will see that, let's put this bigger and let's leave this here. So I'm moving this, nothing happens, let's do it again. Nothing happens until I reach 0.05. Now it's moving. So what's going on here? Basically, I'm sending the DMX data. When I move this, you will see the data. It's channel 4. If I go below 0, nothing. Let's look, because right now we are viewing this in percentage. It's go from 1 to 100. Let's change that to DMX absolute. Yeah, here we go. Now we have real DMX channels. No. There was a way. Well, sorry. There is a way to show this on DMX values. Right now, this is like percentual values. We're going to get confused.
How it looks like VVVV also using normalized values like 0 to 1 or something, from the looks of it.
Yeah, it's basically, well, you need to do this 512, and here you have your DMX value. Okay. 0 will be 0, 1 will be 512. There is a way to view this on this area. Well, so don't worry. Let's go back.
Yeah.
Basically, I want to have control of the light here, but I'm moving from 0 to 5, and nothing is working. because each light have a default position. So if I do clear, 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 and I put the master on 0, if you see the DMX stream, this is not 0. There are a lot of channels that are in different positions, because 0, 0, I mean, when you do clear, clear, clear from this software, it's going to put the position, the fixture on the default position, which is with the noise pointing up. So this is not 0, 0, 0. So we need to tell this software to leave everything on 0. So the way to do that is here. We need a command line. Basically, here this is a command line. I can type whatever here and use it. Let's see. Let me check. There is a way to see the feedback from there's a way to see the command line here. Command line here. Okay, here. Okay. And let me change this window so we can view 10. Okay. Let's save this on this view. Okay, please. Okay, so I'm going to tell the software by command line to turn all these channels to 0. So we have full control from VVVV. I need to do park, fixture. 1 through. I can specify here the another fixture number. If I leave it, if I don't touch anything, it's going to park all the fixtures. What do I mean with park? Park means to force the DMX address to whatever number I put here. So for example, if I put it through at 100, all the channels go to 100. If I 112, I can send all the DMX stream to whatever number I choose. So what I need to do is to park it at 0. So right now, the only data that I'm going to get will be the data from VVVV. So now I have full control of these lights from VVVV, and that's what we were looking for. Okay, so now we can focus on the VVVV side and forget about this visualizing software. All the steps that we made right now are to visualize a DMX stream in the proper way. So now if we have a DMX board, or if we build a DMX board with an Arduino that I will do in the video later of how to solder, we just plug the cable and we plug the cable into the light, and we will have full control of the light from here. The other thing that we need to know, I'm moving here left and right. Number 4 will be tilt. 4 is tilt, and number 2 is fan. So this is tilt. So from here I can move it. Yeah. There is one problem here, David. If I'm using the software in this way, it's quite hard to visualize here, but remember that DMX channels, it's only 512. So if I multiply this by 512, from here I will be able to see what I'm moving. We don't have any decimals, so the DMX stream actually looks like this. So this is the thing. Let's put this on 0. If this goes to 1, try to count how many spins this is going to make. It's going to do 1.5.
Wow,
so
why is that?
This is like because the DMX fixture have different properties. Some of them can do 360 degrees. Another one can do a little bit more.
Okay.
The reason why, if I want to do a program where my lights, for example, let me change the video here. See, I have different ways. Yeah. No. Yeah. Let's say that I want to do an arc and move the light from here to here. I need to move this from here to here, okay? If this fixture only have, I mean, right now it have 360 plus 180, 540 degrees of freedom. This is how this fixture is made at this moment. If this fixture is only 360 degrees, I won't be able, I mean, this goes back to your rotation, everything. You won't be able to do either this movement or you won't be able to do either this movement on the opposite side. Because you will be reaching the end of your, you will be reaching the end of the mechanical, you see? Now, I can move this from here to here, and I can do the same on this other side. But that's because I have 512 degrees of freedom.
All right,
But
I see that.
now we have a problem. Yeah, now we have a problem of resolution, because if I have 512 degrees of freedom, but I have only 540 degrees of freedom, but I have 256. Sorry, yeah, my mistake. It's 256 here.
Yeah, okay.
And I have only 256 positions in resolution for each channel. This divided 256. Each movement will be like 0.2 degrees on the moving head. So it would be like impossible to precisely aim at something because the object is far away.
These devices are not quite famous about being precision devices, though, innit? Oh, that's what your pen fine is for.
That's the thing, David. They are precise. They are very precise, but it really depends on the manufacturer and the equipment itself. The protocol have right now we are viewing a limitation on the protocol side because we have only two degrees of freedom per channel. So how do we fix this? Well, we just use two channels to tell you the position.
Oh, right, okay.
So the second channel, number 2 is tilt. Number 3 will be what is called tilt fine. Tilt fine. So now here I can, when I move this channel, I will be stepping into these 2 degrees that we are not able to reach before. But we don't want to get confused. So there is DMX split value. This is what we need. So from, let's go to 0. How do I show you this? Let's do 512 divided. Yeah, let's do 512 divided. So first is going to fill 0 maximum 1, show slider.
Isn't the divider 256?
Sorry, 500. Yeah, you're right.
Yeah.
So you see, it's going to use the fine channel, and when this goes up and to 0, it's going to go one position on the second channel.
Okay.
So by using this patch, we can express the position using only one gearbox, let's say. So DMX split. This is getting messy, but we will fix it in a second. This is just to explain what's going on. So tilt and tilt fine. This is going to tilt, and this is going to tilt fine, and this is actually the real tilt position. So from here, now I can precisely move my fixture.
Very nice.
So we need this on this channel, and then we need this other one on this other channel. 26, yes, yeah. What else do we need? I mean, each channel have like different attributes. You can do, for example, frost. frost, it's like no, it won't be. You won't see in a visualizer. Oh, here we have like a zoom. Let's expose this so we can use it later. Close and do zoom. And let's see what other thing. Master, field, fan. Yeah. Number 4. Okay, I'm doing something wrong here. 1 and 2, it's pan and pan fine. Number 4 and 5 are here. Number 4, and number 5 until number 5. Number 6 is focus. We won't be able to see this on the visualizer. Number 7 is zoom. Yeah, that's something that we can see on the visualizer. What else? And then we have the globos, number 13, 12. These are the different things that you can project. Yeah, let's do this globos. Almost finished it. So yeah, and this is the output. Okay, so right now I'm going to build this patch for my DMX fixture. I just need, I have 2 ways of doing, now I have 2 ways of doing this. Now, David, you will tell me which one is like more convenient. I can either create the DMX data here. So this is the DMX out data. And that's it. And then I add the DMX data of all the chat on all. No, here, DMX out. And yeah, basically I don't need to use, I can leave this here because this is like an empty, yeah, this is like an empty 512 array. So yeah, I do need this. So the only thing, yeah, this is everything that I need. This is my, like, this will be the patch for my light. Let's do a new one. And I'm going to save this as desktop workshop VL 1000. Reload. Okay, okay. This is my DMX sender. That I can also do like DMX sender. Yeah, DMX sender.
You already had that in the name here.
Sorry?
Yeah, we already had that in the name here.
Yeah. Yeah. Okay. So I need my DMX sender, and I need my desktop workshop body light VL 1000. Okay. So now I should be getting, yeah, control from this light. And we are going to use this. This is a personal wave local. This is a personal node that I made a long time ago. It's quite simple, actually. It's a wave shaper plus an LFO, and yeah. So I can tell 5 seconds. In 5 seconds, this will be going from 0 to 1 in a sine wave. Yeah, here now on the position field. And I'm going to do another one of this here for the field. I think I made up something. David, can you hear me?
Yes, yes, I can hear you. What you messed up?
What? You know what? I think this is. Yeah, no, this is the problem. Because I have like a constant movement here, so this will be like a constant on the DMX output. So I'm going to mess up my router by doing this. It's like you're fielding all the network data.
Okay.
So I'm going to disable this, and I'm going to reduce the.
You know what you could use instead of using plus, using an or, because I know that might.
Yeah, that makes sense. Yeah, here you should have like an or boolean.
But not the bit size.
No, not this
the
one.
bit size
This
or.
one. Yeah. Okay. But I think I did something broken here.
Yeah, you forgot to connect the. You forgot to connect the spread, so the DMX outputs to the you forgot to connect the node to the sender.
Yeah. This goes here, and this one goes here.
And
That's it.
want to change.
Okay.
Connect the other side of the OR. Connect that to change.
To change. Yeah, but if I do this, I'm going to mess up my network right now.
Oh, okay. So, you will going to overload it. All right. Yeah. Sorry then. Yeah. Okay.
I think I have something broken here. Here is working fine. Oh yeah, this one is messed up. This one, 4 on 5, 4 on 5. Yeah, now it's okay.
Is it good?
It was inverted here.
Oh, okay.
Okay, so let's say I want to save this, and I'm going to leave this one moving in this direction, and this one. Yeah, 20 seconds. I think it's working. Yeah, let's do like this. For example, I want to have the light moving in front of me a little bit, so I can, using my node, I can say, okay, from 63 to, I don't know. No, I have something wrong here also. This is on the bottom. This is wrong out. Yeah. Let's do it again. Okay. No, I think I messed up really bad something here.
I'm not quite sure. Your 16-bit node was doing the radix thingy with define and the coarse pin. Yeah.
Yeah. Yeah, but you see that tiny step there? That's not okay.
And number 5. Let me.
No, the step is. Yeah, this is the reason to stop the step. I have like a low refresh rate. Okay.
Yeah.
Let's say I want to have the light moving from here to here. Okay. So the way I'm doing that, I remember. Okay, so it's 0.57. This is one end. I'm going to put this on the minimum, and then I'm going to move this to here. This is like, I don't know. No, David.
Yep.
Yeah, do you hear me? It's this. Having a problem here, Houston.
Hello.
Something went wrong.
It froze down.
Yeah.
Aye. It actually it's a big bug in VVVV or something, that when you're scrolling, when you're grabbing the IO box, it tends to randomly just go off with the Windows error or just stop responding. It's really annoying. But But you know, that's the kind of bug that you can't reproduce because it is so random, and you can't do an example patch because what kind? It's untrackable.
You don't know.
Yeah, but now in this video there was an instance where it was doing it. So yeah, continue on.
Yeah. So let's say I want to have the light moving from this area to I don't know, whatever, this other area. So here 2.36. Prot again. Okay.
Is it alright? It seems to be very slow.
Something wrong. Yeah. But yeah, there's something wrong here.
Maybe to
yeah, now it's working.
Is it working? You know what you should do? Maybe
no, now it's working fine. Yeah.
Okay, but just in case, can you do like a simple renderer with a perf meter in it? Just see which stage it is drawing.
Sorry, you mean this one?
No.
No.
And in VVVV, just do a simple DirectX 9 renderer and just put a perf meter in it.
Yeah.
Yeah, that one. There you go. So if VVVV breaks down, we can at least see that which stage it didn't like.
Okay. Well, basically, we made the light move. Here we have the color, but let's use the power of VVV and the power of Fred to do this in a more clever way. Let's suppose that now we want to control this other guy, this second light. So we can use any plus value. And here we need to be sure that we are going to add the right values and that we are not going to overlap the values. If not, we are going to mess up the DMX protocol. So remember that I made, let's try to clear this thing a little bit because it's quite messy. The color can be here soon. Remember I have here DMX channel. This is DMX channel 1. In the real world, we need to check this other fixture, for example, this one. We need to check here which is the address. Right now, because we are doing this on a software simulation, we need to go to my setup and check here. Okay, the first body light is on universe 1, address 1. Okay, the second one is on universe 1, address 20. Okay. So let's go to VVV again, and here, if I put 20, sorry, 21.
What was that?
I think I didn't park. Something went wrong. Something went wrong. Okay, let's go again. Count, that's nice. I don't know. Let's do a split here so we can monitor our VVV side. What's going on? Okay, and let's put show width. That's like set. Okay. If I go to 20, now there's something wrong on the VVV side because channel 1. Yeah, it's something wrong here. DMX channel 2.
That's interesting.
You see that right now it jumped to. Is it a bug or I'm doing something wrong on my side?
Okay, what are setting all the... oh, I think it was
Let's
just
go again.
overlapping with the well, with the slice, with the slice index number.
Here I have an empty table. Here I have 19 channels,
Yeah.
index.
You know why it's, you know, I know. So you're using set slice. That bin size.
Yes.
That bin size is actually just yeah. You have to use set spread and set the bin size.
Yeah.
Yeah, it's no. Don't do that. Don't do that. Actually, that bin size means that it's a spread of spreads, which is not the case here. Let's stay with -1. And then you have to set the count to this, to the count, yes? And then the offset to the DMX channel, yes?
That's it, sorry, yeah. This live patching. Okay, so...
Yeah, live fixing.
This is alright. 20. There we go. So, now we're moving the light number 20. So, the way I'm doing this, and again, David, you will tell me if there is a better way. I will have this number 1, and I will have this one and number 20. Let's suppose that we have the same movement on the two of them, but we only have a different, we have only a different color. The first one is this one, and okay. So I don't want to connect each color to each light. I mean, it makes more sense to do like a table of colors.
Yeah, you can zip and unzip, of course. You can zip colors and unzip it then. I think you can actually spread the thing. If you were using a zip node in the VL 1000 or 100, what it is. So inside the light patch.
Let me show you the. Yeah, let me show you the way that I was doing this. Maybe then it will show me like the right way of doing it.
All right.
Basically, I was sending sending the color. I was using all the time set advanced, so I can switch later. But basically, receive color advanced. I was getting this one here. If I connect this spread here, I'm going to mess it up because I need to filter this. So I was using get slice color, and I was filtering the whole. I mean, I was doing like this.
Well, first of all,
nicer way.
You can make your node spreadable if you were not using the cons node but the zip node, and so that will be a constant size, and then you can make it spreadable. So you get the right information per light on the right place. Because you can spread the offset, for example, of the set spread, and also so yeah, you can just a simple thing is just replace the cons with zip. I think if you just write in zip, it will just that's it.
That's it.
Keep it, and and you can from now
so
you can
right
also spread your thing.
If I do this. Okay, but you see what's going on. When I connect this one here, everything gets messed up.
Yeah.
So the reason I was doing this in this way. I was using con. Anyway, this is messed up right now because I suppose to. I mean, if I have only one color here, you will see that the two lights are moving like they should. So I was using get.
Oh yeah, previously it was wrong because I think the other one was messing it up as well, or something like that. Yeah. Oh, and maybe the wrong side was as well that you haven't spreaded the DMX channel either. So that's not the aim of this workshop. How to how to get the right spreading actually.
Yeah. Then we will do another one about spread because yeah, this is I mean I'm sure I'm completely sure that I'm doing that I'm doing a lot of VVVV's mistakes here, but yeah, then you guys will be telling me how to do this in the right way. But the reason why I'm doing all these get slides I will show you this in a second. Zoom goes to here, okay, and goes to here, and go, yeah, yeah, okay. So now all my values are being filtered, and then I have here another personal ID that I will be using later. So. Right. Yeah. So now I can have, for example, my two lights doing the same. Each of them have a different color, but I can connect my color spread to the two lights, this one and this one. From my ID pin that is here, I can tell you, okay, be number 3 and be number 2 in color. You see what I mean, David? Now I have different ways. Okay. Basically, that's it. I'm sure there is a better way to spread this instead of making one node per fixture. And I'm sure there is tons and tons of ways to improve how I'm doing this stupid thing.
Yeah,
but this is the way I'm doing it.
Yeah, you have 512 values, and you have to basically set slice them or spread them, and it works. What you're doing works if you can guarantee that the DMX channels won't overlap in themselves. So it won't add to the other one, for example.
Yeah.
So it will only add to numbers which all the other slices are 0. If you know what I mean. You can only do this then.
Yeah, that's what I mean.
Yeah.
That's what I mean.
So,
basically, that's it. What I want to show you here is how.
You promised something with the you have some business with Arduino as well, or we should skip that because of the soldering iron is broken.
I have my soldering iron broken, but I mean, we're going to skip that. I will upload a video for you later.
Okay.
So you can add it to your channel.
All right.
Because I want to show you from here with these two things and the tiny integrate how we can build the cable that is going to be connected to here, and then later I can turn this baby on from here. But I didn't want to skip the date, and I want to show you guys how to use these two softwares to really visualize the data.
Yeah,
this
was very useful actually.
VVVV.
Yeah, this was actually very useful.
But trust me, it's better to visualize the data from here because, for example, if I do, just to give an example, toggle on the position. When I do this, the software is moving the light in the same, simulating the same delay that the mechanical lights have. If you do a 3D render, it's going to be jumping from one side to another, and it won't be what really is going to happen.
Oh,
so that's why I use
this
visualizer. Okay?
Yes, indeed.
And the other thing, I'm not sure about the legal way of using. I mean, I'm not really sure if what I'm doing right now is legal, but I mean, I wasn't sure, and I double checked this on the forum from this company, and I was telling them, hey, I'm a VJ. I want to send data. I want to send color data from my computer to the guy who will be controlling the lights. Is it legal to do it? And it's only yeah. I mean, this software is free for use. You can do anything with this software because this software won't be sending ArtNet data or sending any data at all if you don't have the interface. So if you're using it just to simulate what's going to happen whenever you buy the interface, that's fine with me. That's fine with them. So that means that you can use it basically.
And can you do like a Y splitting of the thing? So you send out your data to this software, but you also send out the data to DMX universe out there somewhere. So, yeah. Because
right now I'm set. Yeah, I mean right now, David, we don't need the software. I mean, if we connect the DMX interface right now, we will be using the lights. The idea of the software is so you guys can start playing with the lights, start viewing how simple this is.
So this software is
without having the software with the interface.
So this software is kind of useless when you have the actual lights and you have the physical environment you're working with.
Yeah, I don't use this software at all. I mean, I do lights from VVVV. That's it. I mean, once you know how this works, you can just connect the data and send the data to the lights and see what the lights does.
Okay.
One thing that is important: there is no way to fuck it up. I mean, it's not like if you send wrong values, you are going to mess up the equipment. That won't happen. In the worst case scenario, I mean, you can send a wrong value and the lamp is going to turn off because there is one channel here, channel 19, that is called lamp control. If you send that channel, I don't remember the right position, but if you send that channel, for example, on 200 for more than 10 seconds, the light is going to turn off the light.
Okay then.
I mean, it's going to keep moving, but the light inside will be off. That's the worst thing that you can do. There is no mechanical thing that is going to be broken if you just move it too fast. But if you don't have, I mean, where I work, I have access to the lights and I can start playing with them just with the Arduino board. If you guys don't have any access to the light or you don't have the board, you can follow the steps that I show you from this software, so you can simulate things from here, and then you can move the lights and use the visualizer to do whatever and all the things from here.
All right. Well, thank you very much for your informative workshop, and well, for guys who are not really into lighting, I hope they will actually use this knowledge for their Christmas decoration, maybe with cheaper DMX hardware.
Maybe.
Yeah, for next year or the next party.
As soon as I can, David. As soon as I can, I will build the interface for you, so you can now upload it to your channel, and we have everything. Right.
Yeah, that would be awesome. That would be awesome if you send the video about it and upload it to the channel. That would be really amazing. Or even you can upload it on your own channel, and I will just link it in the description when you have it.
All right.
Okay.
Well, David, I think that's it. Okay.
Thank you very much, and I hope you guys enjoyed it as well. I haven't dragged on much in the chat. Oh, hey, Westbam stayed with us. That was very heartwarming. Thank you, Westbam, for watching. And and I will upload this as soon as possible. So see you guys.
Okay.
Let me stop the streaming. Bye bye. And stop the recording as well. Bye bye, YouTube.